Hello, Math 7 students. This is Open Up Resources, Unit 2, Lesson 8. This is part 2 in our two-part video series. Remember what we're doing in this particular video is we are trying to compare relationships with equations. In our last lesson, we compared relationships with tables, where we were given tables and we were asked to identify whether or not they were proportional. And we can do that by looking at the table. But what we're going to be doing here is we're trying to transition away from tables, where if all I have is just the equation, can I still identify whether or not it's proportional? And the answer is yes, we just need to build that skill. So in our last video, we had these two different tables, where we were able to find a relationship going across the table using these equations. And after we did that, we noticed that this one, where it had 9/5 c plus 32, that one ended up not being proportional. And this one, where it was c equals 2.54n, that one was proportional. It was proportional, and we saw that in this one that's proportional, we're only multiplying, where in this one that's not proportional, we're multiplying and we're adding. And so now we're ready for our next task. You are given 6 equations here. Based on just how those equations look, and using our previous knowledge from this problem here, I want you to make a prediction on which ones of these 6 equations are going to be proportional. What do you think? Which ones did you predict are proportional? I'm just curious. Luke, tell me which one you predicted. Second one meaning this one, or second one meaning this one? This one? Okay, are there any others that you predict are proportional? Aiden, which one? The one below it? This one? Okay, and Zachary? You think that one's going to be proportional? Okay, good predictions. Anyone else? Okay, some of them are right, some of them are wrong. Let's find out which ones. What we're going to be doing here is we're going to take those equations, we're going to put them in tables so that we can test out that proportionality. And so to plug these in and to use these equations, I have x. And it says what we should be doing with that x is we should add 4, and that's going to be y. So in other words, I take the x value and I add 4 to it. That gives me the y value. That's how I go across that table. Another way that you can do this is simply understand that the equation is 4 plus x. So I'm going to have 4. And here I'm going to be adding x, only the x value it says is 2. So 4 plus 2 is equal to 6. And here, again, it says 4 plus x. So 4 plus, what is my x value this time? 3. And 4 plus 3 is 7. We're going to continue filling out all of these tables using these same strategies. And I'm going to stop here for now because I want us to understand what we're doing in each of these other ones, because some of them look kind of interesting, okay? The next thing that we're going to do here, y equals 4x. Now, what does that really mean? Mathematicians are lazy, so 4x really means, Bertie, times 4, exactly. So the x is multiplied by 4. We're lazy, so we don't often put that multiplication sign, but I want you to understand what that means. So again, that means I'm going to take the x value, I'm going to multiply it by 4, and that's going to give me the y value. Or, if we are using our calculators, I would simply type in 4 times x. So in this case, 4 times x, only what's the x value? 2. And 4 times 2, you can all do in your head. That's 8. I'll do the next one for you. 4 times x, only x this time is 3. So 4 times 3 is equal to 12. Easy enough, right? Okay, let's look at the next one, please. Eyes on the screen. Let's look at the next one. I'll set you loose in a second to start doing all these calculations, but I really want you to see the differences in each one of these. Because do you see how all of them have a 4 and an x? So we have to be really careful on how we're using our calculators and what we're typing in. This equation here means y equals 4 divided by x. So that means y I get by going 4 divided by x, only what is my x? My x is 2. So here it's 4 divided by 2, and 4 divided by 2 is equal to 2. And here it's 4 divided by x, only what's my x this time? 3. That one, that's going to be ugly, right? 4 divided by 3, is it really 2? No, what is it? 1.3 repeating, or fractions are friends, 4/3. Understand what we're doing? Next step. Do you see how similar this equation is to this one? They're pretty close, aren't they? except x is on top and the 4 is on the bottom. So that means I'm going to be, if I want to know what y is, I take the x and then I divide it by 4. So here, the x value is 2, and 2 divided by 4 is equal to 1/2. X divided by 4, only x this time is 3. So I'd be typing into my calculator 3 divided by 4, and that is equal to the fraction 3/4, or we'll go ahead and decimal this one, 0.75. Okay, and this is where it's really important that you're paying attention. So eyes on the screen. Even if you tried working ahead, or I need you to be paying attention right now. Online learners, it depends on what kind of calculator you have, but for my in-person learners, we're going to start like this. This says, I have to move it over. This says 4, and then what? How would I say what's happening here? Kaden? It's not squared because squared would mean it's a 2, and this is an x. So you've got the right idea. What would I call this? Aiden? Close, only it would be to the x power, because we don't know what x is, right? It's the x power. So you've got the idea. We would say that as 4 to the power of x, or 4 to the x power, which means when I'm typing this into my calculator, here, let me rewrite it first. I'll write it and then I'll show you what we would type in. This means that whatever x is, it's going to be the exponent. So 4 to the x power. So what is the x this time? 2. So it would be 4 to the second power, which that one I would read 4 squared. But what is it going to be here? This is going to be 4 to the x power, but x is 3. So 4 to the power of 3. Good. Got it? Now, let's look at the calculator to see how we would be typing those into the calculator. There's a couple different ways. You guys get this fancy button here. Remember that button? It's our template button. Same one we use for fraction. We can also find exponents. So we can go in there and use that. Only it does this weird sort of thing. So that's why it's not my favorite. Because I don't even want to talk about what that means right now. So let's get back. Let's get rid of that. Start with a fresh screen. We're going to do this a different way. I'm trying to do 4 to the power of 2. So 4, everyone type it in. To the power of 2, here's your shortcut. Find this button here. It's 2 over from the 4. It looks like kind of an upside down V. That button, the technical name is caret. Press caret, look what happens. It gives you that exponent box. Even easier than trying to go into your template. Okay? So 4 to the power of 2 is 16. Why is 4 to the power of 2 16? Because what does this mean? 4 times itself 2 times. So 4 times 4 is 16. Let's do the next one. 4 to the power of 3. That's 4 times 4 times 4, which is 64. Okay, so we've got those ones. Let's write those down. 4 to the second power is equal to 16. 4 to the third power is equal to 64. And now let's return here. Y equals x to the fourth power. So again, look at how similar and how different these are, right? The x and 4 have switched places. So this is going to be x to the fourth power, which means I take the x, which is 2, and it's going to be raised to the power of 4. 2 to the fourth power. And here it's going to be x, which this time is 3, and 3 is going to be raised to the fourth power. So let's type those ones into our calculator. Let's get that practice. 2 to the fourth power, 16. Those ended up being the same. I wonder if this next one's going to be the same too. 3 to the fourth power, 81. Why? Think about it. This means 3 times 3 times 3 times 3. This means 4 times 4 times 4. Are they different? Yeah, they are. So 2 to the fourth power is equal to 16, and 3 to the fourth power is equal to 81. All right. So we have explained how we're going to fill out the Y column on each of these. So what I need you to do is pause the video until the Y column on each one of these tables is filled out. You don't need to worry about this column yet. I just want you to do all of these calculations of Y. I will be posting the answers in a second, but I will not be explaining any more of those answers, just showing them so that you can check. Pause the video now. All right, take a look. Make sure that your tables look like mine. Make sure that our Y columns match. Some things to note here. I want you to understand the difference between these two ones again. So remember, 4 to the x power means 4 times 4 times 4 times 4. I'm doing a dot, dot, dot. And the number of times we're multiplying by 4 is x times. That's different than this one, x to the 4th power. That means it's x times x times x times x. We're multiplying by itself 4 times. The x is determined here. So this is 2 times 2 times 2 times 2, 3 times 3 times 3 times 3, 4 times 4 times 4 times 4, and 5 times 5 times 5 times 5. So if you struggled entering that into your calculator at home, if you don't have a scientific calculator that can do those exponents, that should have been what you entered in. Versus this one, where it's 4 times 4, just 2 times, because x is 2. This would be 4 times 4 times 4, 3 times. This is 4 times 4 times 4 times 4, 4 times. And this is 4 times 4 times 4 times 4 times 4, 5 times. So again, make sure that you understand the difference between those. Here we're multiplying by 4 5 times, here we're multiplying by 5 4 times. Now, with that in mind, here's your next step that you're going to complete as you pause the video. Our next column is y divided by x. Understand what that's really asking. What we're really saying is, how do we go forward in this table? I don't know, so I'm going to work backwards, and so I would do 6 divided by 2. And 6 divided by 2 is equal to 3. So how am I going forward? 2 times 3 is 6. Same thing here. How do I go forward? I don't know how to go forward, so I would work backwards, and that's why I have 7 divided by 3. Right here, that's 7 for the y divided by 3, the x. And 7 divided by 3, you can go ahead and give me a decimal, is 2.3 over bar. 2 and 3 repeating. And you're going to continue that process. What is the y value divided by the x value? Make sure you complete your table for the y divided by x. Again, that's going to look different for each one of these. I'll do just a few more for you. Y divided by x, here's the y value 8, divided by the x value 2. Y divided by x is equal to 4. And remember, that answers the question. How do I go forward? I don't know, so I work backwards, and y divided by x, 8 divided by 2, is 4. That means I'm going forward, multiplying by 4. Same thing, how do I go forward? I don't know, so I'm going to work backwards, and that's why I'm calculating 12 divided by 3, which is equal to 4. And repeating that process again for each one of these problems, remembering that we're asking how do we go forward, pretending like we don't know, even for these situations right here. So I can do y divided by x, here that's 2, divided by 2, which is equal to 1. You're going to repeat that, filling out that final column in each of these tables, y divided by x. Pause the video until all of that is done, and then you can check your answers. Pause the video now. All right, check your answers once again. Now with this in mind, do these results change your answer to the first question? Does it change your prediction at all? Again, remember what we were finding. We were finding how we go forward. Here we go forward by multiplying by 3. Here we go forward by multiplying by 2 and 3 repeating. Here we go forward multiplying by 4. Here we go forward multiplying by 4. So that ended up being the same, because when we did that division going backwards, we got the same number each time going forwards. This means that this one here is proportional. That is what many students predicted, that this one would be proportional, but let's check out the other ones. I go forward by multiplying by 3, but here I go forward by multiplying by 2 and 3 repeating, and 2 and 1.8. So we can see that these ones are changing each time, so this one would not be a proportional relationship. continuing on, we can see here we get different numbers each time. So we can see that these ones are not proportional. And here, when we compare these numbers, this is the one that nobody predicted was going to be proportional. And what do you see? Each of those numbers is the same, which means that this one is a proportional relationship. We didn't recognize that it was a proportional relationship because it was division, and we're going to talk about that in just a second. So I want us to first note this was division, so we didn't recognize that it was proportional. But when I do that work, it is proportional. Every time I go forward in this table, I'm multiplying by 0.25 or 1/4. Here we can see these numbers are different, so we're multiplying by different numbers as we go forward and multiplying by different numbers as we go forward, which means these last two, some of the ones that you predicted would be proportional, are in fact not non-proportional or not proportional. So let's take a look at the ones that we predicted. We thought that adding 4 was going to give us a proportional relationship. It definitely did not. Multiplying by 4 we thought would, and it did, because that's what we've seen repeatedly, that multiplication gives us a proportional relationship. What about when I divide by x? That one was definitely not proportional. X divided by 4, that one is proportional. That was surprising for some of us. 4 to the x power, not proportional, and x to the 4th power, not proportional. So let's summarize. When we added, it was not proportional. When we have exponents, it's not proportional. If I'm dividing by x, it's not proportional. Multiplying is proportional, and dividing by a number is proportional. And I want us to imagine and think about why. Why is it that dividing by 4 was proportional? And we've talked about this in the past, that if you saw relationship was dividing by 4, I always wanted you to change that relationship. Dividing by 4 is the same as multiplying by 1/4. So why is it that this division one did work? Because division of a number is the same as multiplying by the reciprocal of that number. So this one was proportional. Do these results change your answer to your first question? For most of us, I'm going to go ahead and say yes, they do. Only y equals 4x and y equals x divided by 4 are proportional. Here's a hint. Only the ones with multiplication worked. Again, make that connection. Why am I saying only the ones with multiplication when clearly this one doesn't have multiplication? It does. We can always rewrite that. Y equals x divided by 4 we can rewrite as y equals 1/4 x, and then we can see that it is multiplication. So again, what do the equations of proportional relationships have in common? I just wrote that one down. All of them are multiplying or can be written as multiplication. All equations of proportional relationships Okay, and again, I want to clarify, all equations of proportional relationships have multiplication. That's why I've always encouraged you to write, when you see division, that you write it as multiplication so that it's easy to identify that they would have multiplication in them. But I want to make another connection here. All equations of proportional relationships have multiplication. Let's connect it to what we saw over here. Here we had multiplication, it was proportional. Here we had multiplication and it wasn't proportional, so focus on why this one wasn't proportional. And it wasn't proportional because yes, we were multiplying, but we also were doing something else. And it's that extra something else that caused it to not be a proportional relationship. We are ready for our summary. If two quantities are in a proportional relationship, then their quotient is always the same. And their quotient is always the same because that is the constant of proportionality. This table represents different values of A and B, two quantities that are in a proportional relationship. Notice that the quotient of B and A is always 5. B divided by A is 5 because we're saying, how do we go forward in this table? I don't know, so I'm going to work backwards. 100 divided by 20 is 5. And continuing on, how do I go forwards? Of course, we do know that 3 times 5 is 15, but if we pretend like we don't know and work backwards, we would be going 15 divided by 3 is equal to that same 5 there. So we're seeing that the quotient is always the same. That quotient is always the same because it represents the constant of proportionality, the number we multiply by as we go forward across the table. To write this as an equation, we have B divided by A is equal to 5, or B equals 5A. However, it doesn't work if A is equal to 0, so just keep that in mind. If quantity Y is proportional to quantity X, we will always see this pattern of Y divided by X has the same value. So again, if Y is proportional to X, we will always see Y divided by X being the same. This value is the constant of proportionality. That's exactly what I wrote up here. Usually, when we talk about constant proportionality, we just refer to it as K. I know we have also abbreviated it as COP when we're a little bit lazy, but even lazier is just using that single variable of K, which means we can represent this relationship as Y divided by X is equal to K because this is our constant of proportionality. We can also rewrite that as our equation Y equals KX, remembering that K is our constant of proportionality. So, if an equation cannot be written in this form, just a simple Y equals a number multiplied by X, then it's not a proportional relationship. That's why every equation that we have written has always been X times some number, let's call it K, is equal to Y, and then we always can reverse that and say Y equals KX. If the equation can't be written to look like this, then it's not a proportional relationship. And now it's time for our cool down. This kind of explains the situation a little bit weird, so I'm going to do my best and kind of summarize it. Andre is trying to set up rectangular tables for a party. If he sets up just one table, he can fit 6 chairs around it. If he sets up 2 tables and keeps them separate, he can fit 6 more chairs around it. So let's think about what that next situation is going to be like. If he set up 3 tables, he would have 6 chairs around each one of those 3 tables, something like that. Another way that he can set them up is kind of in this formation. So we're trying to, first of all, visualize that we've got 2 different setup options. We can have each table separated from the next, or we can squish a few of these tables together, like this. So it says we need to write an equation for the relationship between the number of chairs C and the number of tables T when the tables are apart from each other, like this. Now I don't feel like I have quite enough information yet, so I'm going to build just a little miniature table here to see if I can organize this a little bit better. This will be T for tables and this will be C for chairs. So if I have just one table, so ignore this stuff here, one table, that's going to be 6 chairs. If I use 2 tables, I've got my 6 here, I have 6 more here, so that's a total of 12. If I set up that third table, that's going to be 6 here, 6 here, 6 here for a total of 18. So I asked the question, how does a 1 change to a 6? How does a 2 change to a 12? If you don't know, you can work backwards, but I hope that you see that a 1 multiplied by 6 is 6. So I know that every time I go forward in this table, I am multiplying by 6, and therefore I can write the equation t multiplied by 6 is equal to c for chairs. Or if we wanted to, c equals 6t. This next one is a little bit harder, so I'm going to draw a few more pictures. If we use just one table, but set it up in this formation, well, one table is still going to look the same no matter what. So we would still start our table of values in the same way. With the table and chairs, one table would still be 6 chairs. But let's draw, because it skips to the third one, let's draw 2 tables. 2 tables pushed together. I'm going to be able to fit 2 chairs here on this side, 2 on this side, 2 here on the side of this table, 2 on the side of this table, and of course we got 1 chair on each end. So when I set up 2 tables, but I squish those tables together, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now this one is already drawn for us, our 3 tables. Let's count how many chairs. 3 tables all squished together. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14 chairs. And already we can see that we've got something different happening up here. How does a 1 change to a 6? We multiply by 6. So I can also calculate that as 6 divided by 1, which is equal to 6. How does a 2 change to a 10? That's where things get different. If you wanted to go and find that quotient, 10 divided by 2, well, that's 5. How does a 3 change to a 14? I don't know, so I work backwards. That's going to be 14 divided by 3. And I hope that you're seeing that that is a very different number than what it was up here and here again. See, 14 divided by 3 is equal to 4.6 over bar. So the more tables I put around, the fewer per table I'm able to get. So I think that's kind of interesting. Write the equation here. We did that one. Can we write an equation here? I'm struggling with that. I'm not sure exactly how to write an equation for that because it's not a proportional relationship. Is that first relationship proportional? Yes. Because no matter what, the chairs divided by the tables is equal to 6. It has a constant of proportionality, the COP, or K, equal to 6. Is the second relationship proportional? No, it's not, because C divided by T is equal to 6 over 1, and then it was equal to 10 over 2, and then it was equal to 14 over 3. And notice none of these are equal to each other. And since that quotient is not equal, it is not proportional. I do want to point out just one little reminder here. When it says the equation must be of the form y equals kx, even though I used different variables, I used c and t, it still behaves the same way. It would be y equals kx, where I'm using different variables, but it still is that same format where it's only multiplication. Now, that is it for today's lesson. Please don't forget to complete your cool down in Canvas, and you have your Lesson 8 homework practice problems. That's it. Make sure you get those practice problems done, and we'll see you next time.